So, dear audience, thank you, Elena, for your kind introduction. It's a great honor to be here today, officially celebrating, together with you, my appointment as Professor of Structures and Architecture. Being here today is also a clear sign that my research and design practice have been of relevance for Aalto University, and basically, but not exclusively, it is as the threshold between the two disciplines, architecture and engineering, which is again connected to the sense of responsibility of my future research questions, teaching, embedded into Aalto University's community and efforts for lived multidisciplinarity. And this multidisciplinarity is so important because as engineers and architects, we have to know about our past, we're guessing the future in order to construct the world of today. 1974, the Club of Rome released its Limit to Growth. I overlaid the diagram with Finnish data showing the same trend. Today we have 7.5 billion people living on this planet. And every 3 weeks, our world's population increases by the size of total Finnish population. 2.5 billion people of world's population are kids, which is equivalent to the world's population of 1930. So what happens in 20 years from now, when all these kids are grown up, when they want to live and to work somewhere, when they need some infrastructure to commute from one place to the other, plus the average of consumption of space has grown by a factor of 4. So how can we create 2 to 4 times the world of 1930 within the next 20 years? I think we agree that's simply not possible. And then there is another factor. Where do we get all the material from? Other branches already changed their strategy to the question, will the material be available tomorrow? But the building sector, still unstoppable, consumes like a hungry monster. And simultaneously, the recycling rate is still incredibly low. So how to proceed? How to go on? Opportunities like today's event also offer the possibility, at least for me, to reflect about the past. What about the retrospective view of things that got so defining? Back then, my mother, she was a tailor, and I was quite fascinated by her different materials that she used, and much more by the cutting patterns and the fact that you can make 3D envelopes that perfectly suit you from something that was 2D before. And my father, he was the first inventor that I met. He has been something like a merger of electrical and mechanical engineer. And as a kid, I remember him spending the whole summer on the roof of our house doing experiments. He was a pioneer in solar energy panels in Austria. And still I remember him saying, it's easy to create something from a plenty, but intelligence means doing the same with less. So later in my studies, I learned that he was not the only one talking about less. In this case, it was Mies van der Rohe's less is more. He triggered the modernist revolution. After him followed the postmodern counter-revolution, Robert Venturi saying, less is a bore. And recently, Bjarke Ingels published his architecture comic book, Yes is More. Basically questioning the idea about the architectural avant-garde, which is almost always negatively defined, who or what we are against. So it's the cliché of the radical architect as a sort of young, angry man rebelling against the establishment. And I totally agree with him, trying to bring back this positive approach to design in terms of enjoying the process where projects gradually evolve. So providing this experience in the sense of knowledge and experience in the sense of sensation. From over the aha moment of cognition to the joyful creating of ha ha ha. So designing is thinking by doing. But many times the demand for creating more by thinking more and using less, in other words, the demand for fat-free design, is comparable with an unpleasant diet, where many things are forbidden. But actually, fat-free design is not hindering creativity. It's challenging our approach to give multi-objective answers to present question cast into form. So what is form? What is the origin of form? That simple question I'm asking myself for many years now. And how do we invent form? How do we begin? How do we think of generating a product, a building, a city, a piece of clothing? So maybe it's a preconceived image of a narrative, a matter of artistic sculpting, or perhaps it's the idea of about function, technology, and optimization. And not seldom in the process of design, architects and engineers, but basically architects think they are only responsible for the shape, the artistic expression of the spatial idea. The question of structure is almost neglected, it's handed over to the engineers, and the engineers are to many people are mysterious figures, maybe calculating nerds, problem solvers. But as we learn from this, there is already a problem that has to be solved. And after analyzing and structural development, they hand it again over to realization in a serial process. Michelangelo said, when he looked at raw marble, he saw a figure struggling to be free. The chisel was his only tool. And tools have consequences. At least since the Industrial Revolution, the world of design has been dominated by the regressive manufacturing and mass production. Assembly lines have dictated a world made of parts, framing the imagination of designers, engineers, and architects who have been trained for decades now to think of their objects as assemblies, of discrete parts with distinct functions. But natural things, they are not chiseled. Nature doesn't care about its shape, about its beauty. Natural things, they develop, they grow, they react, and they interact. And you don't find this sort of material assemblies and separation of disciplines in nature. Its tectonics and shape go along with its structure. There is just form, covering various aspects in an optimized way, meaning the best compromise in a parallel process. So these forms are known as self-organizing forms. And from my experience, we respond so much on these forms, on its dynamics, aesthetics, and above all, self-organizing processes generate physically informed forms. So over the years, I accumulated a set of design by research experiments with the aim of formulating a new design approach. DNS, design, nature, structure. So these three things are the things that condition my world. Design as an inspiration, often seemingly simple phenomena. Nature, self-organizing processes and forms. Structure as a synthesis of shape and structure in a structural sense, including fabrication and tectonics. And so the pioneers of such a design approach are few. But like Musumeci, Bowersfeld, Bucky Fuller, Fry Otto, they are the immense instructors. And so these are the intellectual people that I admire. And they were the form finders of the 70s, and they asked themselves not what the object wants to be, but rather what the material wants to be, or what the environment wants to be. Those were the generation of designers that had developed a hands-off approach to design. And that profound implications on the way we develop things, and also great significance is how we perceive this set of ideas about sustainability. And I think they were better design thinkers because they were makers. So how to begin? Nature authors form coming from processes, recipes that mix material and environment together, and due to those mixtures and those relationships, form emerges. Applying that to our field of architecture and engineering, I do believe that real innovation is always happening at the intersection lines. It's not in its core competences, and it's not in its comfort zones. So what phenomena and what intersection can advance our research and design? What I will share today with you is some of my research projects that center around the concept of fat-free design, focusing on intersections in various constellations. Structural membranes still represent a supreme discipline in lightweight structures. Back to tailoring. 100 square meters in one piece, 50 kilograms only. You treat it like your clothing, you roll it, you take it under your arm, and it unfolds its beauty during installation. The shapes represent the perfect flow of forces, its pure form. And it has this unbeatable ephemeral aspect. But nevertheless, membrane structures have their reputation as roof structures only. But what about the potential of membranes as envelopes of architectural spaces? This was the guiding question which was investigated in my doctoral thesis, searching for the rules and principles of self-organized forms like the Catenary. From this we can develop tools which vice versa facilitate our designs, which make us faster, which give us more variations, and which can lead to projects like the Cube of Clouds. A spatial investigation into multi-layer membrane structures, a beautiful example of floating forms and inverting spaces. Inspired by Toyo Ito's Sendai Mediatek, we used Catenoids for spatial and structural purposes. Compared with Le Corbusier Maison Domino from 1915, 2015, the spatial bracing creates space, provides light, circulation, and so on. So these buildings would have a completely different atmosphere. It would be soft spaces. And from the physical models, we learned something really interesting. Over time, the top and bottom blades were deformed by the tension of the catenoids. And engineers would say they were simply not stiff enough. They are bending. They are springs. So we started to read this phenomenon like this, as a sort of bending, active, tensegrity structure, spring-like thing, and developed the Catenoid Tower project from that. Looking at the components, we started with a set of pin joint struts in an irregular skew-width arrangement pinned to plates. Under loading the conditions, the plates started to shift and to rotate until they got blocked by geometrical constraints. Some of them were replaced by catenoids and react on compression, on tension, the elastic plates were deformed. And since the plates were deforming, the whole geometrical setup from position, length, and angles changed, and it ends up in the classical the chicken and egg causality dilemma. So we completed just one loop of iteration of infinite possibilities. The final project, we had two different types of catenoids defined by radius, cutouts of the blades, given distance, eventual collision with struts. And they were kind of challenging tasks in their geometry and prefabrication of the nets. So low-tech meets high-tech in terms of material. Techniques from the Ashley Book of Knots, where you can find almost 4,000 different knots, were combined with high-performance yachting ropes and implemented into our barometric software. So 1.5 kilometers of rope and about 6,000 handmade knots later, the prefabricated and bespoke nets were ready. And we were quite surprised by the fact that our simulation and visualization precisely matched with the realized structure. The final tower was handed over to the public. You could climb it, you could enjoy the spatial qualities, the scenery, and you could relax there. So the Catenary Tower was a highly efficient structure. It could resist 140 kilometers of wind speed. So that means 9 tons of wind load per plate at a self-weight of 2.5 tons only. But the much more important fact, it became part of the natural environment. People missed it after it was disassembled. The textile approach was used as inspiration, as a driving tool to go beyond its own materiality. From a scientific point of view, the female waist is similar to a catenoid. When we designed this dress, the problem of paneling doubly curved shapes with planar elements became visible, a quite current question in architecture. Of course, we can panelize a rotational body into planar elements, but by a textile approach, we received panels which are planar with parallel tops and bottom surfaces and inversely leaning planar sidewalls. And all cuts are linear. And in addition to that, self-interlocking properties of elements by geometry. So you cannot pull or push elements in or out. And as proven by our physical models and digital simulation, even intersections would have these properties, resulting in beautiful dynamic and objects and intersection lines. And later on, we managed to go from 3D file to machine coding for CNC milling to automated production of thousands of individual pieces. And assembled to highly precise matching modules in full scales. And in terms of construction, you simply pile them up. They interlock, done. So from file to build, the whole process was done by mainly 5 people in 2 weeks. And this one was awarded by Timber Structure Award 2015. So what about more flexibility, movability, and kinetics in our built environment? This is an original Stuart Gough platform, which can be described as a parallel 6-degree of freedom mechanism. It is used for simulators, like flight simulators, or like this one. Even irregular arrangements, or having only one telescopic leg, offer enormous movability. But at the same time, all these positions are self-interlocking by geometry. What a potential for architecture and engineering. So this opened the avenue to realize a hybrid of modified Tenured GAF platform with new typologies of double-layer grid shells. A literally lightweight lifting surface of about 30 square meters at a weight of 4 kilograms per square meters only. The modified Tenured GAF effect was used for erection process and later for moving the roof, and according to the movement of the roof, the curvature of the space changed, and the roof panels started to open and to close. So inspiration is ubiquitous. So it's in the textile industry, it's in the art of the clothing, where we can learn from processes and techniques for having new graded materials. We can have it in paper as a non-traditional building material and origami techniques when we realize the probably largest structure ever made of paper only, consisting of 1,200 different double cones, really spanning 75 square meters at a weight of 200 kilograms only, creating awesome light effects. Or the Venus flytrap inspiring the snap action mechanisms that was used for paper modules that snap from plain state into bowl-like objects. And 1,000 of these identical modules were assembled into a freely spanning structure at the exhibition of Nature of Form, Properties of Imagination in Italy. And of course, there is a long and strong relationship between structural membranes and geodesic lines. Geodesic lines are the shorted paths on a surface, and unrolled, they are straight lines again. Alpine coaster is the steepest and longest track in the Alps. It will speed you up to a maximum speed of 50 kilometers per hour, makes 40 hairpin turns, a truly unique hands-on experience, like a roller coaster. Most of the turns are quite shaky. The reason? It is that they are assembled from circular pieces, instead of following a geodesic line. It was the starting point in the discussion with the lift company, and we also spoke about the sad atmosphere at the place where you arrive as a client, where the employees work 10 hours a day. And actually, there is a lot of square meters, but no space. And that is what we made out of it, making this idea of the Alpine coaster, but in terms of a geodesic winding, organizing the space, the flow of visitors, providing seating, shadow, and so on. And visitors and employees, they loved it. So essentially, part of our workflow was the generation of a minimal surface coming from this textile knowledge, providing sufficient curvature for the geodesic winding. So the definition of geometry at a minimum amount of control points in an origami-like constellation, subdividing the surface with a Catmull-Clark algorithm, relaxing the mesh, going through different solvers, including rhinomembrane solvers, have a pre-stressed surface, and then populating this surface with our geodesic lines in form of stripes. And now there are the hard facts. 75 stripes, more than 500 meters of total length of stripes, more than 600 intersection points, and for the students, 3,300 holes to drill. So instead of working in a serial process, we will benefit from parallel processes, using all possibilities of intersection with tools and disciplines, going from observation to realization. But besides all data, the crucial aspect is the logic of form, the logic of material, and the pleasure of space. So the origin of form might be directly related to natural phenomena and self-organization. It's where shape and structure meets in a deeply logic way. And as a designer, you can use this natural principle like a tool. So we can be the 21st century translator of phenomena into spatial objects and spaces. And we can use and experience these things in our everyday life. The way we can start developing things, packaging for ideas, which elevate people perception and the respect for the things, is that what we dig out of the earth and translate into spaces. What we are aiming for is 100% fat-free design. So enjoy. Thank you.